Welcome to Field Science.
So today we'll be looking at circlegeometry or Euclidean geometry, right? So in circlegeometry we'll be discussing all the theorems based on the concept. So let's just take a look at theorem 1. So theorem 1 states that a line drawn from the center of a circle to the chord is perpendicular to the chord. So now we are also given that O is the center of a circle, SR is a chord, and then OU is drawn from the center, which is O, to SR. So given that O is the center, and then SR is the chord, and then OU is perpendicular to SR. So let's try and prove that this line that is drawn from the center, which is OU, actually bisects the chord. Let's prove the converse. The converse says that if a line is drawn from the center of a circle and then is perpendicular to the chord, then this line bisects the chord. So now let's take a look at that. So we're just going to construct. So first things first, we're going to construct OS and also going to construct OR. So now, our proof. The first proof will say OS is equals to OR. Reason being, OS is a radius and OR is also a radius. So a radius is a line drawn from the center to the circumference, right? So radius of a circle is equals to another radius of a circle. So our reason here will be radii, meaning 2 or more radius. When there's 2 or more radius, we say radii. And then, now, we are going to prove this using congruency. So first things first, we'll divide. Remember, OU was divided into 2 angles, meaning, let's say for instance, this is U1 and this is U2, right? So we'll say, in triangle, SUO, right? And triangle URO. Angle U1 is equals to angle U2. Reason being, they are both equals to 90 degrees. Remember, angles on a straight line, meaning this one will also be 90 degrees. So 90 plus 90 equals to 180 degrees. So now, let's also look at this line, these 2 triangles. When we're looking at these 2 triangles, triangle SUO and triangle URO, they have a common side, meaning OU will be equals to OU in both triangles. Reason being, common side, common side, which is equal in both triangles, right? And then let's also look at our the radius. We already know that OS is equals to OR, reason being radii being equal. So we have 3 statements. This angle is equals to this angle in both triangles. These triangles have a common side, which is OU, and then they have both equal radiuses, which is OS and OR. And therefore, these 2 triangles will be congruent. So we'll say, therefore, triangle SUO will be congruent to triangle URO. Our reason here will say a right angle, which is the right angle side, the hypotenuse side, which is our radius, and then also the side, the common side, RHS. RHS will be our reason here. So now, let's go ahead, since here we're required to prove that SU has to be equal to UR, since, well, this line that is drawn from the center actually bisects the chord, meaning when something bisects something, it divides it into 2 equal halves. So we'll say, therefore, SU will be equals to UR. Our reason here will be from congruency or from congruent triangles. Remember, congruent triangles are equal in all respect, meaning this triangle, it's basically equal to this triangle. This triangle here, SUO, it's an exact mirror image of URO. So when you take URO and put it on top of SUO, it becomes the same triangle. They're equal in all respect. Now, we already saw that from the exact theorem, we proved the converse of theorem 1. So from that, we knew that, okay, if a line is drawn from the center of a circle, right? This line that is drawn from the center is actually perpendicular to your chord, right? Then this line that is drawn from the center will then bisect this chord, meaning it will divide the chord into two equal sides, making SU equals to UR, which is proved already. So now let's say, for instance, we are only given that SU is equals to UR, and then we are supposed to prove that OU is perpendicular to SR. How would you prove that? So basically, let's get into that and see how would you prove that. So in this question, we're required to prove that OU is perpendicular to SR. Given in the diagram that O is the center of the circle and SR is the chord, and also given that SU is equals to UR, meaning this side is equals to this side. So basically, from converse 1, we're only given that a line is drawn from the center of a circle, right? And then this line bisects the chord. And then we are required to prove that this line that is drawn from the center of the circle is perpendicular to the chord. We're required to prove that it's perpendicular to the chord. So that's all we're required to prove, that OU is perpendicular to SR. So let's get into that. So first things first, we're going to construct. So let's construct. Going to construct OS and also construct OR. So now from this, so let's go to our proof statement. In this proof, we are going to, after constructing, we are only going to look at the two triangles. We're going to look at triangle SUO, and also going to look at triangle URO. These two triangles. So we are going to focus on these two triangles. Focusing on these two triangles, we are going to say in triangle SUO, and triangle URO, right? SU is equals to UR, right? Meaning this side on this triangle is also equals to the other side, this side on the other triangle. Present being given. So this is given, since we're already given that SU is equals to UR, right? So another thing that we see here is that these two triangles have a common side, UO. So OU is equals to OU, present being a common side. Common side that is equal in both triangles, right? Now, there's also another thing in these two triangles that you might see, that these two triangles have equal radius. So SO is equals to OR. Reason being, these are two radiuses. So it's a line drawn from the center of a circle to the circumference, and it's also a line drawn from the center of the same circle to the circumference, meaning SO is equals to OR. Reason being, radii, or equal radiuses. So now in these two triangles, we have three statements that actually tells us that these triangles, triangle SUO and also triangle URO, are congruent, right? So we can then conclude that therefore triangle SUO is congruent to triangle URO. Reason being that we have this side that is common, we have this side that is equals to this side, our reason being radii, and then we have this side that is equals to this side, which was the side that was given from the initial statement. So we have side, side, side. We have three sides that are equal to each other, right? So now, if we have three sides that are equal, and we already proved that this triangle, these two triangles are congruent to each other, we can now then conclude that these two triangles are equal in all respect, right? Making all the sides, making making all the sides equal and also all the angles equal, meaning this angle here will be equals to this angle here will be equals to this angle, and also this angle here will be equals to this angle, right? And then let's just divide this. Let's make this one u1 and then u2 here, making u1 equals to u2. So we can then conclude that therefore angle u1 will then be equals to angle u2, right? Reason being is from congruency, congruent triangles, right? Congruent triangles are equal in all respect, right? So now, since we know that angle u1 is equals to angle u2, and then we know that angle u1 plus angle u2 is equals to 180, reason being sum of angles on a straight line, sum of angles on a straight line. Sum of angles on a straight line are equals to 180. So these two angles here will be equals to 180. And we already know that these two angles, angle u1 and u2 are equal. So we can choose anyway, right? We can choose anyway. Let's say we already know that u1 is equals to u2, right? So whether it's u1, we can put u2, right? So we can say, therefore, this will become u2 plus u2, right? Remember, angle u1 is equals to angle u2, right? So whether it's u1, we put u2, making u2 plus u2 equals to 180 degrees. This making them angle u2 is equals to, 2 times angle u2. Remember, we have 2 of them. So we have u2 plus u2, making 2 u2 equals to 180 degrees. So this implies that if we divide both sides by 2, this makes angle u2 equals to 90 degrees. So we can see that u2 eventually becomes 90 degrees. So now we can therefore conclude that OU is perpendicular to SR, right? OU is now perpendicular to SR, since we already know that U2 is 90 degrees. So now let's take a look at this diagram alongside with O as the center. And then we're given that SR is equals to 40 centimeters. And then OT, it's given that OT is perpendicular to SR. And it's also given that UT is equals to X. And also OU is equals to 2X. So now the first question, we are supposed to determine the length of OR. And the second question, we are supposed to find the value of X. Since we know that OT is perpendicular to SR, so we'll go ahead and put a 90 degrees here, since we know that OT is perpendicular to SR, right? And then we are also given that UT is equals to X, which is already there, and then OU is 2X. So now we're supposed to determine the length of OR. OR, this distance here, distance OR. So now, how would you find the distance or the length of OR? So we already know that OR is the radius, right? So we'll go ahead and check radiuses on this diagram. OR is the radius. OS is also a radius. And also, OT is also a radius. So now, we'll eventually know that, okay, OR is equals to OT. Reason being, radii or radius are equal to radius that are equal to each other. And then we already know that OT is equals to OU plus UT. So this implies that OR will be equals to OU plus UT, since OT is equals to OU plus UT. And we already know that OU is equals to 2x, so where there is OU, you substitute 2x. And where there is UT, you substitute x, giving us OR equals to 3x. This implies that OR will be 3x, and also OS will be equals to 3x. So now, let's find the value of x. Now, let's find the value of x. Since we're here, finding the value of x, we'll have to go back to the statement and check what is given. We're given that SR is equals to 40 centimeters, meaning the distance from here to here is 40 centimeters, right? And then we know that from the converse, a line drawn from the center of the circle is perpendicular to the chord SR, and also this line bisects this chord. It divides this chord into two equal sides, giving us, making SR equals to 40 centimeters, and then SU, making SU equals to 20 centimeters, and then UR is also 20 centimeters, since, well, this chord is being divided into two equal halves. So now, we can eventually see that we have this triangle here. And then this triangle has a 90 degrees here. So let me go ahead and draw it alongside here, just to make it simple for us. So this triangle is like this. And then we have 2x here. We have 3x here. And then we have 20 centimeters here. Right? So now, we are supposed to find the value of x now. So from here, we are going to use the theorem of Pythagoras. This theorem of Pythagoras is going to be OR squared, which is equals to OU squared plus UR squared from the theorem of Pythagoras. And then we also know that OR is 3x. Since what is the radius? OR is the radius, which is 3x squared, which is equals to OU. OU is already given that OU here is 2x. So we'll put our 2x here. 2x squared plus UR. UR is 20 centimeters, which is here, giving us 20 centimeters squared. Now, 3x squared gives us 9x squared, which is equals to 2x all squared gives us 4x squared plus, and then 20 squared gives us 400. Right? So now we are going to solve for x. We are going to take this 4x to the left hand side, giving us 9x squared minus 4x squared, which is equals to 400. And then 9 minus 4 gives us 5x squared, which is equals to 400. And then we are going to divide both sides by 5. And then this 5 will cancel this 5. And then 400 divide by 5. So now 400 divided by 5 is equals to 80. So therefore, x squared will be equals to 80. And then, since we want x, we'll put a square root on both sides. Therefore, x will be equals to, we'll punch our calculator looking for a square root of 80. So now we'll say 80 into the square root, giving us 8.944. So a root of 80 will give us 8.944.